Hello students, I am Ayush Sir and today I am going to discuss about the interference of light waves. Okay, we know that light can behave as the wave or as the particle depending on the different situations. Okay, so here we are considering that light is behaving as the wave. That's why we are studying the interference of light waves. Okay, so what is the meaning of interference? So in our daily life or in our daily talk, we always say this: don't interfere in his life, don't interfere in my life. So actually interfere means we say that do not try to interrupt my personal life, do not try to interrupt personal life of any other person. So here interference means interruption of wave due to another wave. Okay, interruption of one wave due to another wave is the general idea of interference. But since we are doing physics, so in physics, the mathematics will be involved and some physics will be involved. So in that perspective, the interference will be different. But in the general talk, interference means one wave of light will interrupt another wave of light. If this is happening, then we will say interference is taking place. Okay. Now, in terms of physics, we define interference like this: if two or more light waves of the same frequency, condition of interference, frequency should be same, means wavelength should be same. If if the two light waves are in the same medium, then if the frequency of two waves are same, speed will be same, speed of the light wave will be same in one medium, right? So wavelength will also be same. So if frequency should be same, wavelength should be same. Great. If such two light waves are overlapping at any particular point, then the resultant effect at that particular point will depend on the phase of these two waves. Okay. Phase means they are in phase, they are out of phase, or they are having some phase changes. Okay. And the amplitude of these two waves. Okay. Now this was the very general definition of interference. Now we will understand with the diagram. So let's say this is wave 1, this is wave 1, and this is wave 2. Okay. Now see, their frequency is same. The frequency is omega, and frequency is omega of this wave 2 also. Okay. Now in this case, I have taken the amplitude of these two waves also. You can take the amplitude different, no problem. Okay. Now if these two waves are interfering, then you can see the phase of these two waves is same. It is also starting from mean position. It is also starting from the mean position, and this is going above, and this is also going in this direction. So the phase of these two waves are same. So if these two waves will overlap, they will give a wave, resultant wave, something like this. This is a resultant wave. Okay. Resultant wave. Great. Now you can see the amplitude of the resultant wave is larger than the amplitude of these two individual waves. It is clearly visible. Okay. The amplitude. I am taking A. Okay. So it is greater. It is greater because these two waves were in phase. The phase of these two waves was same, or you can see the phase of these two waves was 0. Now, if I have to take the two waves which are out of phase, see this wave. The frequency of these two waves is same. This is again wave 1, and this is again wave 2. The frequency of these two waves is same. But and amplitude, again I have taken the amplitude same. You can take the amplitude different, no problem. But one is starting from the origin, another is also starting from the origin, but one is going in the upward direction, but another is going in the downward direction. So these two waves are out of phase, means the phase angle between these two waves are 180 degrees. So if these two waves will overlap, they will give you a 0 amplitude, because this positive amplitude of wave 1 will nullified by this negative amplitude of wave 2. Similarly, the positive amplitude of wave 2 will nullify the negative amplitude of wave 1. So the resultant wave will be the amplitude of resultant wave will be 0. Okay. So this is how the resultant wave after interference depends on the phase of two waves and the amplitude of the two waves. Great, great. Now let's understand the mathematics. Okay, mathematical formula, mathematical equations we will understand. So now let's say we have taken two source points. One is source here, another source is here. This is two source I have taken, and these two sources are obviously generating light waves. And these light waves, let's say this is a point P, and let's say these light waves are interfering at this point P. Okay, okay. These two waves, these two light waves are interfering at this point P. Great. And let's say the wave equation of light waves from source 1 is given by EA will be is equal to E1 sine omega t. This E and E1 are these wave equation I am writing in terms of the electric field vector. Okay, yeah. See, light waves can be written as electric field vector or the magnetic field vector. So I am writing here in terms of the electric field. Similarly, the light wave that is emitting from source 2 can be written as EB is equal to E2 sine omega t plus delta. Now, this delta is the phase angle between these two waves, wave A and wave B. I have taken this phase delta because we don't know what is the phase between these two waves. So I have taken a arbitrary phase, a German phase, and we will see. And on this phase, the resultant wave will depend. If it is in phase, then we will get the maximum amplitude. If it is out of phase, then we will get the zero amplitude, as we have seen right before. Great. Okay. Now, if I have to write the resultant wave, so the resultant wave, let's say ER, I am taking the amplitude of the resultant wave as ER, can be written as EA plus EB, right? So now let's add them. EA is E1 sine omega t plus EB is E2 sine omega t plus delta, right? Right. Okay. Now let's write E1 sine omega t as it is, and let's open this sine omega t plus delta. So it can be written as sine omega t cos delta plus cos omega t sine delta. This is the formula of sine A plus B, right? Yeah, I'm assuming you are aware of this. Okay. So E1 sine omega t plus, now multiply this E2 sine omega t cos delta plus E2 cos omega t sine delta. Okay, okay. Now ER is equal to, now let's take the sine term together and let's take the cos term together. Okay. So see, sine omega t is present in this term and sine omega t present in this term. So let's take the sine omega t common. So we will left one E1 plus E2 cos delta sine omega t plus E2 sine delta cos omega t, right? Okay. Now let's assume that E1 plus E2 cos delta is equal to E cos phi. Okay, I am assuming this. I will tell you a little later why I am assuming E1 plus E2 cos delta equal to E cos phi and E2 sin delta is equal to E sin phi, because I want to write down the resultant wave equation in terms of this E sin omega t plus phi. I want to write the resultant wave equation in this form. That's why I am assuming E1 plus E2 cos delta is equal to E cos phi, and I am assuming E2 sin delta is equal to E sin phi. Okay, okay. Now let's write the resultant wave equation. So now ER can be written as E1 plus E2 cos delta can be written as E cos phi and sine omega t, right? Plus E2 sine delta can be written as E sine phi cos omega t, right? So now let's take E common. So we will be left with sine omega t cos phi plus cos omega t sine phi, right? So can we write this as sine omega t plus phi? Can we write it like this? Yes, we can write it like this. Great. If we can write it like this, then ER is E sine omega t plus phi. So this will be the amplitude of the resultant wave. Amplitude of the resultant wave, right? Right. But in this equation, two unknowns are present. Which are those two unknowns? One unknown is E. We don't know what is E. We know E1, we know E2. Now we know ER, but we don't know what is E. E is unknown. सही बात है. And phi is also unknown because we don't know what will be the phase of this resultant wave with the original wave. Great. But we have assumed something. What we have assumed? We have assumed that this is equation first and this is equation. Now let's try to calculate this E and phi from this equation. Okay. So let's write this equation 1 and 2 here. Equation 1 and equation 2. क्या है equation 1 and equation 2? Let's write that. E1 plus E2 cos delta, E1 plus E2 cos delta is equal to E cos phi, and E2, let's see, yes, E2 sin delta is equal to E sin phi, right? This was equation 1 and this was equation 2. Now let's square these two equations. So equation 1 will become E square cos square phi is equal to E1 plus E2 cos delta whole square, and equation second will become E square sin square phi is equal to E2 square sin square delta, right? Now let's assume this equation third and this equation fourth. Now add equation third and equation fourth. Great, let's add. So if we will add these two equations, then we will get E square cos square phi plus E square sin square phi. Great. And E2 square sin square delta plus E1 plus E2 cos delta whole square, right? So in this, let's take the E square common. So we will be left up cos square phi plus sin square phi will be is equal to E2 square sin square delta, and let's open this. So we will get E1 square plus E2 square cos square delta plus 2E1 E2 cos delta, right? We have just opened this bracket. That was I have used the formula A plus beta whole square. Great. Now E square, we know this sin square plus cos square will get 1, so we will be left with only E square. Great. Now this is E2 square sin square delta and this is E2 square cos square delta. So let's take the E2 common. So E2 square, and in the bracket we will be left sin square delta plus cos square delta, and then we will have E1 square plus 2E1 E2 cos delta, right? So E square will be E2 square. Now this again will become 1 sin square delta plus cos square delta plus E1 square plus 2 E1 E2 cos delta, right? If this is E square is equal to E2 square plus E1 square plus 2 E1 E2 cos delta, then we can write it like this also, that E square is equal to E1 square plus E2 square plus 2 E1 E2 cos delta, right? So now we have got which equation? The equation of the amplitude of the resultant wave. What was the amplitude of the resultant wave? This was the amplitude of the resultant wave. Now we have got the amplitude of the resultant wave in terms of the amplitude of the individual waves. E1 and E2 was the amplitude of the original two waves, and delta was the phase difference between these two waves. So now you have got the amplitude of the resultant wave. But what was the equation of resultant wave? The equation of resultant wave was ER is equal to E sine omega t plus phi. So now we know this E means amplitude of the resultant wave, but we still don't know this phi. Okay, so let's calculate this phi. So again from equation first and second, equation first and equation second. Now let's divide equation second by equation one. Okay, so equation second divided by equation one will give us E sin phi divided by E cos phi. We will be left with E2 sin delta divided by E1 plus E2 cos delta, right? Let's check we have written the right terms or not. E1 plus E2 cos delta, E2 sin delta. That's why we have to E will cancel out, right? So we will be left with 10 phi is equal to E2 sin delta divided by E1 plus E2 cos delta. So now we know this phi will be equal to 10 inverse E2 sin delta, yes, divided by E1 plus E2 cos delta. So now we know this, we know the amplitude of the resultant wave, and also we know the phase of this resultant wave, right? Right. So if we know these two things, then obviously we have got the resultant wave equation. So these two equations are important. So I want you to write it down. I will highlight these two equations. Okay, so this one is important equation. Okay, this will be used in many questions, also in many formulas, and this is also important. I will highlight these two equations. Great. And I am star marking also this, so that you will remember these two equations. Okay, now let's get back to the original slide. So yeah, see, we have got this equation, yes, and we have got this equation, right? Okay, I'm also highlighting this, yes, and again I'm highlighting this one. Okay, great. Now I have calculated the amplitude of the resultant wave, great, and I know the amplitude of the individual shift that was interfering, right? Now I want to calculate the intensity of the resultant. Okay, so you know what is the formula of intensity? Intensity actually is proportional to the square of the amplitude. Okay, and this comes from this formula. This is the formula of the intensity. Okay, this is the formula for intensity. I can be written as half epsilon naught P E square, where epsilon naught is the permittivity of the vacuum, P is the speed of light in the vacuum, and E square is the amplitude of the electric field which the light wave is coming. So now I have written down the intensity of the light wave in terms of the permittivity of the medium, speed of light in vacuum, and the amplitude of the light wave, right? So from this you can see From this, you can clearly see this C and F balance for one medium is constant. C and epsilon naught for one medium is constant. Epsilon naught will again be constant, and C will also be constant. Great. So this intensity will depend on what? Intensity will depend on E, right? So that's why the intensity is proportional to the square of the amplitude. If this intensity is proportional to the square of the amplitude, so now let's see how we can write the resultant amplitude equation, this equation, in terms of the intensity. Okay, let's see. See, if I is proportional to E square, right? So I can write I in place of E square, right, is equal to, and I can write the I1 in place of E1 square plus I2 in place of E2 square, and plus this is E1 and this is E2. So if I is proportional to E square, then root I, if I will take the root of both sides, then root I will be proportional to E, means root I will be proportional to the amplitude of the light wave. And obviously I1 and I2, I am assuming the intensity of the individual wave that was intercepted. Okay, yeah, I1 was the intensity of wave 1 and I2 is the intensity of wave 2, right? So if I have to write intensity term in place of E1, so I can write root I1, right? Because root I is proportional to intensity, amplitude, sorry, and I2, and cost term will remain as it is, right? Cost term will remain as it is. Great. So can we write the intensity terms like this? Yes, we can write the intensity term like this. Okay, great. So now we have achieved this. I is equal to I1 plus I2 plus 2 root I1 root I2 cos delta, right? Now, obviously, this is depending on two factors, on the intensity of the individual light wave and the phase difference between those individual light waves delta. So now, for case 1, let's talk about the case 1. So for case 1, delta, if delta is 0, okay, let's take the delta is 0. So what will be this equation? So I will be equal to I1 plus I2 plus 2 root I1 root I2, and if delta is equal to 0, what will be the value of cos delta? This will be 1, so it will be like this. Okay, so I will be equal to, so can I write this equation as root I1 plus root I2 whole square, right? If you will open this up, just apply the formula of A plus B whole square, then you will get the same equation that is written above, right? Right. So this is the maximum intensity that can be written as root I1 plus root I2 whole square. This is maximum intensity. Why? Because the maximum value will be when the value of cos delta is maximum, and the maximum value of cos delta can be what? The maximum value of cos delta can be plus 1. Okay, the minimum value of cos delta can be -1, and the maximum value of cos delta can be +1. So I have taken the delta is equal to 0, so cos will give the maximum value. Okay, great. So this is the maximum intensity at any point. Okay. 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 Let me write it again. Okay. Let me write. I just want to highlight this point. So I'm writing it root I1 plus root I2 whole square. Okay. And I am highlighting this point so that you remember this point. So this is, you have to remember that the maximum intensity happens when the phase difference is 0, and the maximum intensity is root I1 plus root I2 whole square if the I1 and I2 are the intensity of the individuals. Okay, okay. Now let's see the case 2. Okay, case 2 is what? In the case 2, I am taking delta is equal to 5. Okay, if delta is equal to 5, what will be the value of cos delta? Cos delta will be equal to cos 5. It will give me -1. Okay, so now let's put this value in the equation, that is I is equal to I1 plus I2 plus 2 root I1 root I2, and cos delta will be -1. So this will be I is equal to I1 plus I2 minus 2 root I1 root I2. Okay, so I can write this equation as root I1 minus root I2 whole square. Is that correct? Yes, it is correct. So this is the minimum intensity. Why I am calling this the minimum intensity? Because the value of cos delta will be minimum when delta is equal to pi, and the minimum value of cos delta is -1. The minimum possible value of cos delta can be -1. The maximum possible value of cos delta can be +1. So that's why I am calling this intensity of the resultant wave is minimum. Great. Again, I am highlighting this equation. So this equation you should remember. Okay. Okay. Great. Now these two equations I have achieved the minimum intensity equation and the maximum intensity equation. Great. But now let's take a special case. Okay. 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 Let's see what happens. Special case is this. Special case is this. If the intensity of the individual wave are same. Let's say the intensity of I1 is equal to I2 is equal to I0. Means I have taken the intensity of these two individual waves, right, waves same, and I0. Okay. So if I will put these intensity in the case 1 that we have discussed before, means for in the maximum intensity equation. So what was the formula for maximum intensity? That was I max is equal to root I1 plus root I2 whole square. Right. Now let's put this value. So I max is equal to root I0, right, plus root I0 whole square. Right. So this will be 2 root I0 whole square. Right. So what will be the maximum intensity? The maximum intensity will be 4I0. You can clearly see the maximum intensity is not 2I0, because the intensity of individual wave was I0. So from the intuitive brain, we assume, or we tend to assume that the maximum intensity will be I0 plus I0 2I0. But you can see if the intensity of the two individual waves are same, then maximum intensity is not 2I0, it is 4I0. It is due to the interference term that we are getting this. This is known as the interference term. What term? Interference term. Okay. This 4I0 is coming out this due to this interference term. Great. Great. Now, let's calculate the minimum intensity from the case 2. What was the formula for minimum intensity? I minimum is root I1 minus root I2 whole square. Now let's put the value of I1 and 2 same. So root I1 minus root I1 is equal to 0. So you can clearly see this will give us 0. So minimum intensity will be 0 and the maximum intensity will be 4I0 when the intensity of two individual waves are same. Then the maximum intensity will be 4I0 and the minimum intensity will 0. Maximum intensity you will get when the phase delta is 0, and minimum intensity you will get when the phase delta is pi. Correct? Yes. Okay. Now we have seen the minimum intensity, the maximum intensity, The intensity at phase 0 is maximum, the intensity at phase pi is minimum. Now I want to calculate the formula of intensity for any random phase, and in a compact formula, in a compact phase. Okay, so now let's calculate. So the formula of intensity is I is equal to I1 plus I2 plus 2 root I1 root I2 cos delta, right? So if again I am taking this case of same I1 is equal to I2 is equal to I0. Okay. So now let's put this in the above equation. So we will get I is equal to I0 plus I0 plus 2 root I0 cos delta. Great. I will be is equal to 2 I naught plus 2 I naught cos delta, right? So let's take 2 I naught common. So we will get 1 plus cos delta, right? So I will be is equal to 2 I naught. I can write 1 plus, I can write cos delta as 2 cos square delta by 2 minus 1, right? So minus 1 plus 1 will cancel out. We will be left up 2 I naught 2 cos square delta by 2. So we will get I is equal to 4 I naught cos square delta by 2. Now this is again a very important equation. You must remember this equation, because by this equation, by this formula, many questions will be solved in your exam. So just remember this formula. Again, I am highlighting this formula. So, and this formula is valid when 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 intensity of the waves of the individual waves are same. Means I1 should be equal to I2 should be equal to I0. Then only this formula is valid. Okay. Okay. So we have studied the interference, the intensity of interference, the amplitude of interference. When is maximum intensity we will achieve, when the minimum intensity we will achieve, and we have studied what will happen when the intensity of two individual waves are same. We will achieve 4 I naught maximum intensity when the individual wave intensity is same, and we will achieve 0 minimum intensity if the intensity of two waves are same. And this is the formula for any general phase difference. So this is depending, if you know the intensity of the individual wave and the delta in phase difference of the individual wave, then you know the resultant intensity. Okay. I hope you have understood. Bye bye. Thank you.